just to give you a preview of what this matrix representation can be good for, I'm going to use a slightly different representation. Remember, we have the system 2x plus 3y equals negative 2, 4x minus 5y equals 18. We write that in shorthand notation of a matrix, putting the 2, 3, 4, negative 5 here, just as we did when we wrote this as a matrix equation. And we augment the matrix. This is called an augmented matrix. We augment the matrix by putting down the right-hand side, negative 2 and 18. We put a dotted line here to separate the left-hand side from the right-hand side. It's easy to see that this represents the system of equations. The 2, it's understood now that the 2 is a coefficient of x, coefficients of x here, coefficients of y here, and right-hand sides here. So this really means 2x plus 3y equals negative 2, 4x minus 5y equals 18. Now, we're going to manipulate this in a way that's just completely similar to the way we manipulated the equations a little bit earlier. Remember that we multiplied the first equation by 5 and the second by 3 in order to line up the y coefficients. Now we're going to do the same thing. We're going to take 5 times the first row. Not sure how clearly that is, but that says 5 times first row. And multiplying these numbers, we clearly get what we get. 5 times 2 is 10, 5 times 3 is 15, 5 times negative 2 is 10. Multiplying 3 by the second row, we get 12, negative 15, 54. You can check the multiplication yourself. So that's just like multiplying the two equations by these numbers. Now, next thing we want to do, and this is going to deviate just a little from what we did, but it's the same idea. We replace the first row by what we get when we add the first row to the second row. Now you remember that, if you remember before, we added the first row to the second row. That eliminated y. Now why we put this in the first row, don't worry about that right now. That's what we do. We'll go through it in more detail later. This is just a preview. So when we do that, we get 22x, 0y equals 44. Second row hasn't been addressed, so it stays the same. Then we take the first row and we divide it by 22. Having done that, we get 1, 0, 2. They're very easy to divide these numbers by 22. And what does this mean? This means x plus 0y equals 2. In other words, x equals 2. And remember, that was one of our solutions. So we've got our solution for x just by manipulating these numbers according to a certain set of rules. And those rules correspond exactly to what we do when we add and subtract multiples of rows to and from one another. Okay, so we have this matrix. Now what can we do with this matrix to lead to a solution for y? Well, we want to eliminate x. Now we have 12x minus 15y equals 54. Okay, we have 12, negative 15, 54. We want to add a multiple of this row to get rid of that 12. If we get rid of that 12, then, well, you'll see what happens, okay? We take negative 12 times the first row and add it to the second. Negative 12 times the first row is negative 12, 0, negative 24. If we add that to the second, the negative 12 adds to this 12, giving us 0. Negative 15 stays where it is because we had no y here. And the negative 24 adds to the 54 to give us 30. And this is what we get. So that goes here. And then we simply divide the second by negative 15, and we get 1, negative 2. And this reads 0x plus y, 1y equals negative 2. In other words, y equals negative 2. There's our solution. Now again, we're going to do this in more detail and more explicitly. This was just a 5-minute teaser at the end of the class since we had the time to do it.